Good afternoon, everybody. This is a live severe weather update as we have a tornado threat unfolding across northern Minnesota. This is a classic QLCS tornado event, or quasi-linear convective system with embedded supercells. Here you can see the reflectivity image here from northwestern Minnesota across the immediate Thief River Falls area. There's also another tornado warning that's been issued to the north for a circulation between Middle River and Holt, Minnesota. And it's pretty hard to see the individual circulations on reflectivity, even though the stronger ones, you could definitely see those ramp up. Here you can see one of those circulations near the Holt area, just to the southwest of Holt. Quite a bit of a ramp up there. The rear flank downdraft indicated with one of those circulations embedded within the line. Moving off to the south, there's that circulation that was near the Thief River Falls area. And the good news is that it looks like it has weakened a little bit on approach to Thief River Falls. There you can see that circulation when it was just to the south of Carpenter's Corner. And that was heading toward Thief River Falls. Looked like a very dangerous situation was unfolding. It looks like that circulation has weakened just a little bit to the south of the Thief River Falls area as it's heading in toward Hazel. But if you're in the Hazel area, you definitely want to take shelter. Be in your safe place watching this, because these things can spin up really quickly. And there's definitely an embedded QLCS mesocyclone there. They can spin up to tornado strength within a radar scan or two. And here is this circulation near the Holt area. That could be the tornado wrapping up there just to the south of Holt, with a little bit of an RFD surge indicated by radar. But it's possible too that that's just a radar artifact there to the south of Holt. But you can definitely see these embedded circulations. There's the circulation that was on approach to the Holt area. That tornado warning extends way off to the east, including the Gadsden area, Griegla, south of Skyme. This is the north country of Minnesota. Pine forest up here, a ton of lakes as well. A lot of people in the outdoors, probably enjoying the outdoors, fishing, maybe canoeing out across northern Minnesota. And these are fast-moving circulations. These are moving at like 50 miles an hour, embedded within that line. Zooming out, you can see the widespread severe thunderstorm warnings from eastern North Dakota back into northern Minnesota. And there's another tornado warning too to the south of to the northwest of Fargo that I've been keeping an eye on. And these look like similar to landspout tornadoes. There's an extreme amount of low-level instability here. There's convective rolls that are visible on radar. I'm about to pull up this radar here right now, show you that storm to the northwest of Fargo. Here's the circulation. And there's definitely a mesocyclone embedded within this too, to the west of Arthur, North Dakota right now, to the southeast of Page. This is using the Radar Omega app here to break down radar. And you can also look at this in 3D. And I do think that this is more of a landspout setup right along this convective line. But there's a fine line between landspout tornadoes and those that can be associated with the mesocyclone. Sometimes landspouts will develop and they'll form under a weaker mesocyclone. They'll couple with that mesocyclone and act to intensify it. That Martin, South Dakota tornado is an example of that. Last year in southern South Dakota, that was kind of one of those landspout morphing into a mesocyclonic tornado type of a situation. And this is a convective line that's oriented southwest to northeast. It's roughly parallel to the flow. There's extreme low-level cape, low-level instability, a lot of stretching potentially for these. But there's also quite a bit of bulk shear. So it really just takes a slight adjustment of the storm motion, or maybe a slight intensification of the low-level jet, maybe a slight backing of the winds to really turn a non-tornadic storm into a tornadic one. This one, though, does have a mesocyclone. We could definitely see on radar just to the west of Arthur. It's not very tight, kind of a broad mesocyclone, but it definitely is there. And really any landspout or eddy that develops underneath this vacuum cleaner of a mesocyclone is a candidate to get coupled with it and then turn into a mesocyclonic tornado, and could potentially be a damaging one at that. And we're breaking down a tornado threat right now in eastern North Dakota into northwestern Minnesota. And even though many of the models, especially the HRRR, were showing that northern Wisconsin looks like the most favorable zone for tornadoes this late afternoon and evening, with those dew points in the low 70s, subtle lead disturbance out ahead of the main vortex, Looks like it could contribute to a tornado threat across northern Wisconsin. But there is a complex of stratiform rain, some convection in there too, that's moving toward that target area that could act to mitigate the tornado threat there. I guess you could call it an MCV or mesoscale convective vortex. But if just enough instability can get up there in northern Wisconsin, then I think that there is a supercell and a tornado threat up there as well that we're going to break down later on this afternoon. But now we want to break down the more immediate tornado threat. This is the one to the northwest of Fargo. This looks like a supercell storm. You can see a hook-like appendage on the backside. We've already shown the broad mesocyclone on velocity. And really, it'll only take one eddy or even a landspout, a gustnado to migrate underneath that vacuum cleaner of a mesocyclone to couple with it and develop into a potentially damaging tornado there. As to the southwest of Arthur, North Dakota, here's a line of similar storms that are trying to develop into supercells. This one, I believe, had a tornado warning earlier, but it's kind of lost its storm relative inflow a bit. These storms are pretty close together down here, too, merging together as you'd expect when they're oriented along a convective line from southwest to northeast that's pretty parallel to that upper level flow. Usually you get a lot of mergers of these individual supercell storms, which can act to weaken the tornado threat. You can see a little appendage of an earlier supercell even on the back line or back flank of this convective line. But I could definitely see landspout tornadoes within this convection as they interact with those moist convective rolls, stretch those into the vertical, and any transient mesocyclones will lead to even more stretching and tighter vortices at the ground level. So keeping a close eye on that storm. If you live in the Arthur area, you definitely want to take shelter. And even this one has a tornado warning now. This includes the Hillsborough area. And look at that hook on the back side. This is pretty close to the radar, so it's harder to see. But you can definitely see a hook-like appendage on the southwest side of the storm, just a few miles to the west of the Hillsborough area. Let's look at velocity on this one. And there is keep in mind this is pretty close to the radar, but if there was a tornado in progress, it would still have a very tight velocity signature on radar. But looking at this, even though it is pretty close to the radar site, just to the northwest there, just about 15 miles away, I'm not seeing anything that jumps out as a tornado in progress with this storm. But on velocity, you can certainly see that hook-like appendage coming around, and it's very possible that this radar beam is scanning below where that intense rotation is developing. Usually the rotation will drill down from aloft down to the ground, and you can actually track it using the different elevation angles of the radar beam. So let's go back to velocity. This is the first tilt, and not much rotation there, but let's go up to tilt 3. Stand by. No, we'll go to tilt 2. It's a little bit higher up, and you can see some more velocity signatures there on the second tilt. That's the elevation angle of 0.8 degrees. And I bet if we were able to go up a couple more scans, even higher up in the storm, we'd probably see a pretty stout mesocyclone. But here you can see a possible couplet that's pretty close to that hook-like appendage on the backside of that storm, just to the west of the Hillsborough area. Going back again to radar reflectivity, you can see this hook. This is the high-resolution radar data of the Radar Omega app, and you can definitely see that hook-like appendage to the west of Hillsborough. A lot of inflow coming in from the due south here in the Hillsborough area. So this could be a tornadic storm. You do have southerly surface winds, though, that are getting impeded by this convection off to the south. So it is possible that this storm has a pretty small window to produce a tornado. But it doesn't need a big window when the ingredients come together. And this is the Red River just to the east of it, so it is going to be moving into Minnesota eventually. There is a severe thunderstorm watch for this area. And there you can see the couple of tornado warnings that have been extended for this QLCS pattern, quasi-linear convective system up here. Could look at the Duluth radar or Grand Forks. It's definitely in a radar hole, though, here in northern Minnesota. but you can definitely see where those circulations are located. It's definitely a smart call just to issue these very large tornado warnings, because any of these little circulations embedded within, this is the strongest one just to the southeast of Hazel, moving east-southeast, could impact the River Valley, Roland, Minnesota areas, High Landing. Here's another circulation near the Mavi area, and also another circulation to the east of Holt. And it's pretty incredible that these are so far away from the radar, and you can still see the mesocyclones that are leading to the tornado potential at ground level. This is using the Grand Forks area radar, and you can definitely see that those mesocyclones, even QLCS, tornadic mesocyclones, extend pretty deep into the troposphere, pretty high up into the troposphere. So this is the most dangerous QLCS circulation right now, just to the southeast of the Hazel area. And these are moving rapidly off to the east at 50 to 60 miles an hour. So definitely stay tuned to those warnings. I know there's a lot of outdoor activity that happens out here in northern Minnesota. So now I'm going to break down the environment that these storms are moving through. Here you can see the main wave. This is the main trough that was also responsible for that incredible tornado in southwestern Manitoba. I think that was 2 days ago, not yesterday, but Friday. This system has just become vertically stacked. It's just dominating up here. And this convective line is forming on the eastern fringe of that stronger 500 millibar flow. And the cooling as well at 500 is moving in here from west to east. But really this convection formed on the eastern fringe of pretty strong mid-level flow. You can see 50 knots here, 40 to 50 knots. Accelerating up to 80 knots up there. And then you've got this MCV, or mesoscale convective vortex, that's moving toward northern Wisconsin. That could be an area that leads to tornado potential across this zone in northern Wisconsin. It's associated with its own cyclonically curved mid-level flow. And just ahead of that, there's going to be southwesterlies at the mid-levels, stronger southerlies as well. Some more favorable wind shear. And this is actually the primary target of most storm chasers today across northern Wisconsin. The storm chasing terrain is very difficult up there. Dense pine forest as well in northern Wisconsin. But there are some holes in the pine forest up here, some chaseable areas in northern Wisconsin. I actually chased up there back in 2011, April 10, the day after observing numerous tornadoes that extended overnight and during the previous evening on April 9, 2011. That was the beginning of the most active month in recorded history in the U.S. for tornadoes, April of 2011. And then we intercepted some fast movers up here in Wisconsin. Joel was on the storm that was near Siren, Wisconsin. And there was actually snow on the ground. Lakes were still frozen. And we were chasing fast-moving tornadoes through northern Wisconsin on that day. This is a very different setup. This is more of an MCV, a lot of moisture, an isolated, smaller scale area of favorable wind shear that's going to emerge. Maybe there's some more uncertainty with that eastern target. But looking at the convective line that's been prompting those tornado warnings so far this morning, plenty of surface-based instability along this convective line just ahead, just on the eastern fringe of that faster mid-level flow with the cyclone above and along the cold front here. But you could definitely see a lot of convection forming across eastern North Dakota. Extreme instability, so there's a ton of low-level cape out here. There's some moist or horizontal convective rolls as well, some horizontal vorticity that can get flipped up into the vertical and lead to some landspout tornadoes that can morph into supercell tornadoes. And then up here you've got circulations that are embedded within a linear convective pattern. So we call that QLCS type tornadoes moving into northwestern Minnesota. And then off to the east, you can see that mesoscale convective system moving into northern Wisconsin, and some surface-based instability, a ton of it developing ahead of that MCV as well. So now looking at the storm relative helicity in the lowest kilometer, you can definitely see that it's non-zero across northern Minnesota. But when a squall line forces a storm motion even further to the right than is indicated by those models, that's when they can even develop a greater tornado threat within a convective line than even an isolated supercell could out ahead of it. And then you can see how that wind shear tails off with southwestern extent. And as that front gets more southwest to northeast. It's more parallel to the mid and upper level flow. But really up here is the QLCS tornado threat moving into an area of synoptically more favorable wind shear. And then you've got this MCV type of a pattern that usually in the late season, in the middle of the summer, they could be your best bet for intercepting tornadoes, especially across the upper Midwest up here. But there's a lot of uncertainty associated with those. Usually the tornado threats are pretty conditional with these MCVs. And that could be the case today across northern Wisconsin as well. But good to see all the storm chasers headed up there. You're not going to see a tornado if you don't chase it. And these storms aren't going to chase themselves. So I think it's important to have eyes on these storms and reporting those tornadoes as they do happen. But quite a complex severe weather setup that we have going on with a QLCS tornado threat up here to the east of Thief River Falls, closing in on this lake country of northern Minnesota. Look at all these lakes. But they're going to go north of that area, far northern Minnesota up here. This is the most dangerous area, but eventually heading toward these lakes, Upper Red Lake, Lower Red Lake out there, the Ponamai area, Redby, Waskish. I'm sure it's a beautiful area up there, but if you're engaged in some outdoor activities out here on these lakes, you've got some dangerous storms that are moving rapidly toward your location, so you definitely want to keep your eye out. Stay tuned to those warnings using NOAA Weather Radio, using weather apps like Radar Omega, like the one that I'm breaking down right now. And you don't want to be stuck outdoors. You saw that photo near the Black Hills area from yesterday. There was a mom that was protecting the lives of her children, and she got struck in the head by a big hailstone, blood and everything. She's definitely a hero for protecting her kids, but that just shows you that you need to stay tuned to the weather reports, the severe weather potential before you head outdoors and do those outdoor activities and enjoy the beautiful summer months. But these are the QLCS tornadoes that are embedded within the line. Beltrami County, Marshall County, northern Minnesota out here. It's kind of in a radar hole as well. And there's also this tornado warning very close to the radar site as well, near the Hillsborough area. We were tracking that circulation that was just to the west of Hillsborough. It's very close to the radar site as well. Not much of a circulation down there. But on radar reflectivity, you can certainly see a hook-like appendage. And it looks like this storm is weakening quite a bit as it's passed through the Hillsborough area. There is a bit of convection to the southeast that's impeding the inflow into this hook echo here, the circulation. So the good news is that this supercell is weakening just a little bit as it passes off to the east of Hillsborough, but you can still see that hook-like appendage there. But some convection has developed in the inflow region, probably associated with outflow that seems to be impeding the inflow into that main mesocyclone that prompted the tornado warning. Here's a blob of convection that is definitely helping to mitigate the tornado potential with this storm as well. And that's a good thing because it passed right through Hillsborough, North Dakota. And then this one is also still tornado warned for a broad mesocyclone on its southwestern flank. Looks like that circulation is near Arthur, North Dakota now. So I'm keeping a close eye on that as well, near the Arthur, North Dakota area. You still want to be in your safe place. So that's what we're looking at with this tornado threat. I'm going to continue with these live updates. I'm going to head over to the supporter portal as well, and we're going to break down the environment that happened in southwestern Manitoba with that big tornado that was intercepted by Sean Schofer. Aaron Jajak was up there as well. And we'll break down that environment, break down some of that footage. And it was interesting because the environment didn't look incredibly favorable for violent tornadoes up there. You may remember that we braked it down the morning of that Manitoba tornado. Yeah, Joe, I'm breaking it down from home right now. Break it down the radar. Could have gone all the way to northern Wisconsin, but the bust potential with it just seemed a little bit high to justify the 25-hour drive or so out there, maybe like 35 hours or so round trip. So figured out it could be more of a service, breaking down the radar on that one from a distance, breaking down the QLCS tornado threat across far northern Minnesota. We're watching very closely the tropics right now for the potential development of Josephine down the road. So we're keeping a close eye on the tropics. We're definitely going to be chasing the tropics hardcore the rest of the year. I'm waiting on the subsonic sensor from Mark as well. He's going to be shipping that down soon. I'm really excited about that. Basically measuring the heartbeat of these storms, including hurricanes, tornadoes, other ones. We're going to be deploying that inside the eye of a hurricane because it requires basically calm winds. Because when the winds ramp up, they can really drown out the signal, subsonic signals. So we're going to try to deploy that inside the eye of the hurricanes. I do think this is going to weaken a little bit as it moves off to the east. This isn't an incredibly high tornado threat, but it is non-zero. It looks like this circulation now is to the east of Hillsboro. So this is the circulation in eastern North Dakota here. This is definitely still a dangerous storm. It weakened a little bit as it was moving through Hillsboro, and now seems to be ramping up again. There was an old circulation back with the hook of that one, and now it looks like this new one has taken over. That is now to the east of Hillsboro, moving off to the southeast. And as we saw in Manitoba, sometimes these southeasterly movers can generate their own storm relative southerly flow. So if you have a 10-knot southerly wind and your southerly component of the storm motion is 15 knots, you're looking at a storm relative southerly wind of 25 knots. So that's how storms can create their own shear in a storm relative sense. And that happens a lot with these southeasterly movers. It happened up there in southwestern Manitoba as well just a couple of days ago. I wish I could have been chasing up there, but the border situation is still not favorable for me to get to Canada. There you can see that hook now to the east of Hillsboro, North Dakota. Right now it's 2:56 Central Time. And this is moving off to the southeast, so really the forward flank is roughly parallel to the storm motion off to the southeast. It does look like some of this convection to the east of the Alton area, to the east of Kelso. It's probably some kind of a left split. Definitely looks like it's about to impede the inflow into the storm, so if it does have a tornado threat, it is relatively narrow of a window. Let's look at the longer term loop, and it does look like that's a left split that's heading off to the north. It's definitely attempting to impede the inflow into the storm, but there is a narrow tornado threat as this right mover is turning southeast. A left mover to the northeast of Kelso is moving off to the north, about to intersect with that storm. Thief River Falls, you had that QLCS circulation move through. Thankfully, it looks like it weakened a little bit on approach to town, but doesn't mean it's not a damaging storm that moved through earlier. Even if there's not a tornado threat, when you get these embedded mesocyclones within a fast-moving line like this, they can create tornado-equivalent winds that can still be deadly. And look at those little appendages stick out ahead of that line. That's where you can kind of see the inflow or where those embedded circulations are developing. This one's just to the east of Garnes, Minnesota, in northern Minnesota there. A couple others that are trying to develop further south within this line. But this thing probably has kinks up and down it. If you were looking at the shelf cloud of this, you would look up and down and see inflow kinks up and down that line, and that's where the tornado threat exists with that line. This one's now approaching it blew through the Gatsky area and is now passing between Skyme and Griegla in northern Minnesota. There's a new radar. So that circulation is passing just to the south of the Griegla area, and these are moving rapidly. They're moving at 60 miles an hour or so. So if you're on the upper and lower red lakes out ahead of this convective line, you definitely want to take shelter. These things are approaching rapidly. You're not going to have a lot of time to get off the lake with these approaching, but this one's passing just to the south of the Grigla area. Pretty intense rotation. QLCS, mesocyclone, embedded within the convection along the leading flank of that shelf cloud. So that's a pretty dangerous situation there, even if there's not a tight tornado cyclone with that. Usually the westerlies and the RFD portion of that line can be so violent, trees coming down, that it could still be a deadly situation there. And again, that is passing just to the south of the Grigla area. 2 tornado warnings up there. Then you've got this one to the east of Hillsborough that's approaching the Red River. The one off to the southwest near the Arthur area has been allowed to expire as that circulation has weakened. And so far, that MCV moving toward northern Wisconsin has not yet developed a tornado threat, but you can definitely see this outflow boundary surging off to the southeast. It's probably about to shut down the tornado threat in eastern North Dakota with that one. But these QLCS circulations will probably keep going for a long time, moving through northern Minnesota, and then we'll have to watch northern Wisconsin for development of severe storms to the north of Eau Claire, to the east of Moose Lake, south of Lake Superior, just to the southeast of that MCV. So thank you, everybody. And this afternoon, I'm going to go live on the Facebook supporter platform, breaking down the southwestern Manitoba environment. We'll look at some of Sean's footage, and we'll go live as well if there's an increasing tornado threat with this line across northern Minnesota, or if additional supercells develop out ahead of that mesoscale convective vortex. Thank you, everybody, and have a good rest of your day.